Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA Physics Specimen Paper 1 higher tier. Question number 7 is on the topic of electricity or electric circuits. A student set up the electrical circuit shown in figure 9. So you have what is a series circuit with 3 resistors. Now these are your resistors. A 45 ohm resistor, a 60 ohm resistor, and one labeled R, and that's your ammeter, which is supplied by a 12 volt battery, because it's not a cell, each of them is a cell, so this is a battery, and because they are all one after each other, they are in series, and S is actually the switch. The ammeter displays a reading of 0.10 amps. So the ammeter reading is 0.10 amps. Calculate the potential difference across the 45 ohm resistor. Now the potential difference supplied by the power supply is 12 volts. There's a total of 12 volts. Because it's in a series circuit, that potential difference or voltage is actually shared between the components. If it is a series circuit, it's going to be shared. So part of the energy is going to go to the resistor R, then to the resistor 60 ohm, and then 45. The total potential difference should add up to 12 volts. Now, how do you calculate the potential difference across the 45 ohm resistor? We use the equation V equals IR. V is the potential difference, which is what we are trying to find for the 45 ohm resistor. We know the current in a series circuit is going to be the same. Doesn't matter where in the circuit, the current is always going to be the same. So the current is 0.10 multiplied by 45. That gives me 4.5 volts. 7.2. Calculate the resistance of the resistor labeled R. How do you calculate the resistance labeled R here? Now, if the current in the circuit is 0.1, we will need that. If we find the total resistance in the circuit using the potential difference that is supplied and the current, I can find the total resistance in the circuit. And then I know the resistance here in this resistor and this resistor, and then take away these two values from the total resistance, and I will actually get the value of R. So for 3 marks, the total resistance, right? We're still going to use V equals IR. If I rearrange the equation, R equals V over I. So the total resistance is the potential difference in the circuit divided by the current in the circuit. That's 12 divided by 0.1. That gives me 120 ohms. Now, if I take away from the resistance, R is going to be 120 minus the 60 plus 45, which is 105, and that should give me an answer of 15 ohms. Question 7.3. State what happens to the total resistance of the circuit and the current through the circuit when switch S is closed. Now, what happens to the total resistance in the circuit? That's going to be 1 mark. And what happens to the current through the circuit? That's going to be a 2nd mark when you close the switch. So let's have a look at the circuit again. If you close this switch S, what happens is the current, as it goes through the ammeter, it passes through the resistor R here, and then instead of going through the 60 ohm resistor, it short circuits. It finds a new path because the switch is now closed. Current flows through the path of least resistance. So if the current actually goes through this, then the total resistance of the circuit actually goes down. Why? Because this resistor is not effective. Now, if the resistance goes down, that means the current actually increases, because now the current is not being slowed down. So the answer, the total resistance decreases and the current increases. Next part. A student investigated how current varies with potential difference for two different lamps. The results are shown in figure 10. So as you can see, we have a line graph for a filament lamp. The potential difference is going from 0 to 10, and the y-axis is the current. And you've got lamp A on the top and lamp B. Question: complete the circuit diagram for the circuit that the student could have used to obtain the results shown in figure 10. So they have given you the power supply and they want us to complete the diagram. So let me extend the line. Yeah. Let me make sure that it's just a straight line. So to that, you would need an ammeter to measure the current, and the ammeter needs to be in series. To the ammeter, we connect the bulb or the filament lamp, and then in order to change the potential difference across the filament lamp, we need to add a variable resistor. And the symbol for a variable resistor is this. That's your variable resistor. So we are going to use the variable resistor here to change the potential difference in the filament lamp. And the current is going to be measured here. The bit that you need, or the equipment that you need, is to measure the potential difference across the lamp. That needs to be measured using a voltmeter. Right? Here we go. Next question. Which lamp will be brighter at any potential difference? Explain your answer. Use figure 10 to aid your explanation. Now, if you were to look at the graph, the line for A was on the top and line for B is there. Which of these lamp is going to be brighter? It is going to be lamp A. Why? Well, for lamp A, at any of the voltage, this 10 volts according to the graph, at any voltage, the current in lamp A is always higher than in B. Now, if there's more current, then it's going to be more brighter. A is brighter because it has a higher current than lamp B at any potential difference. Therefore, A has a higher power output than bulb B. Now, the second sentence is where most students would actually not gain the marks. What does that actually mean? We know that A has a higher current than B. So what does that mean in terms of power? Power is the amount of energy transferred per second. Current is the rate of flow of charge, and the charge carries the energy, which is the voltage. So A has a higher power output. So more energy is actually being transferred in A than in B. Question 8.3. Lamp B has a higher resistance at any potential difference, which would make sense. That's why the current is actually low. Explain how figure 10 shows this. The reason that B has a higher resistance for any potential difference is because the current is always lower. The lower current than lamp A for the same potential difference since it has a lower gradient than lamp A, and we can also refer it to the gradient as well. Question 8.4. Both lamps behave like ohmic conductors through a range of values of potential difference. Use figure 10 to determine the range for these lamps. Now, what does an ohmic conductor mean? An ohmic conductor is a conductor which obeys Ohm's law. So, what does Ohm's law mean? Right? Ohm's law is basically this equation, V equals IR. What does that tell you? It tells us that the voltage or the potential difference is directly proportional to the current, provided the resistance is kept constant. And for a graph which actually shows this relationship, it should be a straight line going through the origin. So potential difference and the current. Now, if the line goes through 0 and this bit is directly proportional, and if it's directly proportional or a straight line, then we call it an ohmic conductor. So how does figure 10 show that it is a ohmic conductor, and what is the range for this? Let's have a look at the graph again. As you can see, it's more or less a straight line only for a couple of parts. So if I was to draw a straight line, let's see if I can draw that properly. So redrawing it, if you use a ruler to draw a straight line, right, it shows that for lamp B it's somewhere between 0 and 2 volts, and lamp A probably about A. So right, use figure 10 to determine the range for these lamps. Explain, right? So it's going to be between 0 and 2 volts, right? And the explanation is, for an ohmic conductor, current is directly proportional to the potential difference, so resistance is constant. Now, if for it to be an ohmic conductor, you need to make sure that you mention that the resistance is constant. That brings us to the end of the video, and I will see you in the next video for questions 9 to 11, because we've got 3 more questions to do, and we'll do all 3 questions in one video. Thanks for watching. I will see you in the next video.